Hello there. In the previous video, we introduced you to the HVACR in general. The link to the previous video is given below in the description. Here, we will be more specific to discuss how the system works from two perspectives, the heat transfer approach and the thermodynamics approach. However, in this video we will start by covering the heat transfer approach. DX system transfers heat from one area to another through the evaporation and condensation of a special fluid called a refrigerant, which serves as the medium through which heat is absorbed from one area and rejected in another. This system is composed of four major components: the compressor, the condenser, the expansion valve, and the evaporator. The compressor is mainly the pump of the refrigeration cycle. The condenser and evaporator are heat exchangers, while the expansion valve is to expand the refrigerant from the high to the low pressure side of the cycle. Well, depending on the type of compressor used, the direct expansion system is either the single speed type or the variable type. The single speed type achieves constant refrigerant flow throughout the cycle during operation. However, the variable type changes its speed, and thus refrigerant flow as demand varies. Now, imagine yourself sitting in an office room with other employees. After some time, you will start to feel uncomfortably hot. Have you ever wondered from where this heat came? Heat is generated by occupants themselves. Here in your case, it is you and your colleagues, from lighting, and from appliances like laptops, servers, and even your printer. Also, heat is transferred through the walls and ceiling from the outside, and infiltrated through what you think are tightly closed windows and doors. All these are sources of heat that disturb your comfort while working in your office. Now, to compensate for this heat generated, one or more air conditioners are introduced to the area to eliminate this heat and absorb it through the evaporator. Carrying the heat away through pipes, the condenser allows the refrigerant to reject the absorbed heat into the outside. This balance between heat generation and heat rejection maintains a comfortable environment inside areas and spaces. Similarly, heating an area employs the same cycle. However, the condenser and evaporator are opposite. The evaporator, now outside, absorbs heat and carries it in pipes to be rejected in the area to be heated through the condenser. In both applications, cooling and heating, heat absorption and rejection are attained through the gradient of temperature between the air and the refrigerant. This temperature gradient allows for heat flow from the higher to the lower temperature side. We will elaborate more on this idea in the next videos. And by this, we come to the end of our session. In the upcoming video, we will discuss microscopically how these systems work from the thermodynamics perspective. Thank you for listening, and don't forget to like our video and subscribe to our channel to stay updated with our latest videos.